Okay, here is something pretty cool. So I have a 9-volt battery, a normal light bulb that runs up to 3 volts, not 9 volts. Okay, and then I have here, I don't know if you can see this. This is a light bulb, but I broke the light bulb and I just have the filament in there. So normally in the filament, in the light bulb, this filament, I don't know if you can see that. This filament is the part that current runs through and it gets really hot, so hot that it glows. Okay, so that's the filament. So I'm going to connect everything together. I'm going to run the current out of the battery to the bulb through the filament. I've connected to these 2 posts here, and then back to the battery. So let's do that. And it lights up. You can see that lights up, not this. This doesn't have enough current going through it to light up. If it did, bad things would happen. Okay, now for the cool part. Watch the bulb as I blow on the filament. Watch right here. Notice that the filament gets brighter when I blow on the filament. This light bulb gets brighter when I blow on the filament. So what's happening is that when I blow on this, and I saw this in a book, and it was really cool, so I wanted to try it. When you blow on the filament, it cools off. And it turns out when things get cooler, their resistance goes down. So let me show you a quick diagram about how this works. I already drew this out for you right here. Okay, so here we have a wire. That's the filament. The resistance of this wire depends on the cross-sectional area, the length, and rho, the resistivity. Okay, we're not changing the area, we're not changing the length, those are set. But the resistivity depends on the type of material and the temperature. So if I know the resistivity at some temperature T0, and I know the coefficient of thermal resistivity, I can't remember what alpha stands for, then with the change in temperature, I can calculate the new one. But the point is, as delta T increases, rho increases. And the resistance of this wire depends on the resistivity times the length divided by the area. Okay, so if this increases, the resistance increases. If the temperature decreases, the resistance decreases. So here's my circuit diagram. Here I have battery, EMF for electromotive force, that's what we like to use. Current comes out and it goes through the filament and the bulb. So I have 2 resistors, the filament resistance and the bulb resistance. So this is my loop rule. So if I add up the voltages around this whole loop, I get 0. So I have EMF and then minus IR for that resistor, minus IR for that resistor. You can combine those together. So I get EMF minus I times the sum of the resistances equals 0. If I solve that for I get this. EMF over RF plus RB. The resistance of the bulb does change because it gets warmer too. But mainly, if I decrease this, that will increase the current. And with increased current, I get a brighter bulb. And that's it.